Okay, everyone, so we are here. We are going to do a review of PEMDAS backwards as one of the premier methods of solving quadratic. So, you know it's a PEMDAS backwards scenario when you have this scenario where you have in parentheses an x squared type scenario. And this is usually the most effective way. And so if I look at this side of the equation, it was built first by I subtracted 5, squared it, multiplied by -1, and added 4. So if I would build that thing, I start off with x, and then I would have subtracted 5, and then I would have squared it, and then I would have multiplied by -4, and then I would have added a 1. And so I'm going to do this backwards. That means I'm going to subtract 1. I'm going to divide by a -4. I'm going to square root it, which is the opposite of squaring. And then I'm going to add 5. I'm going to do it in this order because I built it this way. If I start with x, subtracted 5, squared it, multiplied by 4 negative, and then a plus 1. So I'm going to undo it. I'm going to first subtract the 1, so -4. X minus 5 squared is equal to -36 by subtracting the 1 over. Dividing by -4 both sides, which gives me x minus 5 squared is equal to 9. And then if I square root both sides, I get x minus 5 is equal to, here's the tricky part, when I take a square root, plus or minus. Okay? And because there's a square here, I should expect to have two solutions. Now that's not a 100% rule, but that's a pretty common scenario. And so then finally, I've square rooted, I'm going to then just add 5. So it's going to be plus or minus 3, add 5. Well, that means there's two solutions here. Plus 3 plus 5, which is 8. -3 plus 5, which is 2. And so I have two different values for x. And so I'm going to double check that with Desmo, see if I'm on the right track. And so I put it into the graph already. And I have the parabola going upside down because it's negative. I have -35, so in order to find it, I gotta scroll down, go up to -35. Oh, there it is. Okay, and there is my one point of intersection, 235. My other point of intersection, 8, -35. And so I verified it with Desmos. I can tell they're the correct answer. The one thing I will add, let's consider this last scenario here. Let's say if I ended up with an x plus 1 squared equal to 7. And then I would have to square root it. And I would have x plus 1 is equal to plus or minus. Well, this is really messy. I'm just going to leave it exact. Square root of 7. And then I subtract the 1. X is equal to -1 plus or minus the square root of 7. And this here are the two values. So I don't actually simplify that. It comes out to a cleaner answer when this is, excuse me, a perfect square, but that doesn't always happen. That's just a tip, remember, for the future.